So today we'll be filtering yeast. So I've already set up my plate. This is a YPD plate, and I have my control. And so I'm gonna use unknown for A type, and then I'm gonna put that here, and then I'm going to use alpha ADE1, and I'm gonna put that here, and then I'm going to mix the two for my sample. Here I have it clearly labeled here. And so to do that, we're going to flame our loop here. Get it nice and hot. I'll let it cool off for a second. We'll put any more samples. And we'll be able to do this in one quick swoop. We're going to do the unknown 4 first. Check my thing is cool. I'm going to make sure I put them in the right spots. I'm going to grab a little bit of my sample. I'm going to put it on the sample spot and streak it back and forth evenly. Okay, and then I can actually take the same exact sample and put it on my unknown for control. And then I will flame the loop to clean it off. And I'm going to do the opposite so I don't contaminate my alpha. So this one, you can already see they're streaked, and this one, and then this one, and I'm going to streak this one first, and then I'll streak the sample last, so then I don't contaminate my control. So doing that control first here, and then now we're doing the sample. Mixing those two. Okay, and then we'll flame it again, sterilize our loop for next use, and then we'll incubate this, our sample. I'm also going to make sure I clearly label it that it's mine. Okay, here's my label, KDH, Bio 260. And then I'm going to go put that in the 37-degree incubator right over there. Okay, so I am going to answer how we are defining the ADE mutation. And so by that, I am going to show our pathway here. This is the normal pathway of how these where these mutants are in the pathway. And this ADE2 is what we're looking at for when the mutation, or what mutation we're looking at and testing to see whether it is present or whether it is not present. And so if it is blocking the pathway when we cross our unknown with one of the ADE types, one of the ADE strains, then we're going to have accumulation of this AIR, which is why the outcome on the agar plate will turn red, because that is accumulating in all the vacuoles. And that is in a source that I will quote at the end of all of this. And then, yeah, so we were just mainly looking at the ADE2. And then this, if the ADE1 is blocked, which is then why we see the white. Actually, that's wrong. But if this isn't blocked up here, it's not going to accumulate that red. So then we're going to go all the way and make adenine, which is then why we see the white outcome on the agar plate. And then down here, also, this was just the type of yeast that we were using. I'm not even going to try to pronounce that because that's a long word. And then the next question, we were explaining the role of the A and the alpha mating types. I found this picture, and I'll also cite this at the end of this. This is a really good picture. I thought that described it in really simple terms. It basically states that we have the one cell, which would be an alpha cell, and it will bud and make another one, which will then be known as the daughter cell. And then actually, um, the original parent one will actually flip to the other type, which is now what we call A type. And it says right here the daughter cannot switch until it also has budded, so it will end up switching too. So we both have them as type A, and then or the mother is both, it has budded and now it is type A, and then the daughter is still alpha. And then they are going to mate and form zygotes, which will then become our group of yeast. So we're basically going from a haploid generation, two haploids, to a diploid generation. And then those will multiply and bud off and create more yeast buds.